Hello, students. Mr. Murphy here, Module 5, Lesson 4, Discrete and Continuous. So a set of data is said to be discrete if the values belonging to the set of data are distinct and separate. They're not connected. And you're going, what are you talking about, Mr. Murphy? I don't know this data, this discrete, blah, blah, blah. This is the way it works. So let's say we have a table of data, right? So I'm buying bags of candy, or maybe it's Takis, and here's how much it costs. Can you buy 1.5 bags of Takis? No, I can't go in the store and rip open a bag and then say, I'm buying 1.5 bags. You have to buy 1 bag or 2 bags. But if I drop a stone, I can measure how fast it's going or how far it went every half second. But I can measure every 3/4 of a second too. I could measure the distance it went between a half a second and 1 second. The stone doesn't disappear and then reappear a half second later. It travels through that area. So that's a continuous function. So the discrete function is where I jump from one bag to the next bag, but a continuous function flows right on through. Okay. More specifically, there's restrictions on what I can put in for the x in a discrete function. There are no restrictions on what I can put in for x on the continuous function. So which of these graphs is discrete? So the first graph is discrete, and how do we know? Because it's just a bunch of points, whereas the second graph is continuous because there's a straight line connecting all the points. So on a graph, that's the difference. On a table, you have to look at the problem and say, does it make sense? I can buy a half a bag, yes or no. On the graph, it's going to be distinct points or it's going to be lines. Now, sometimes they may just put a bunch of points on there and tell you it's a line, but normally you can just tell if they're asking you and there's no words. A straight line would be continuous, while individual points would be discrete. And word problems also can be discrete or continuous. So James sells cars. His pay is structured with a base pay and a commission on every car he sells. If he earns $1,500 per car sold and has a base pay of $300, what function could you write to determine his weekly paycheck? Right? So he's got the base pay of 300 plus $1,500 per car. Is that discrete or continuous? Well, does it make sense? Can he sell a half a car? No, he can't sell half a car. So that is a discrete function. And notice we use the f of x instead of y. This is a function, not necessarily an equation, but most of the time there's no real difference, right? A fighter jet accelerates at a rate of 80 miles per hour in 1 second. What is the function for speed over given time? Right? So the function would be 80 miles per hour per second, right? So in 1 second, it's doing 80 miles per hour. In 2 seconds, they're doing 160 miles an hour. And in 3 seconds, they're doing 240 miles per hour, going really fast, okay? Is this discrete or continuous? Well, can you measure how fast the jet is going after 1.5 seconds? Yes. So there is no jumping from second to second. It's a continuous measurement of speed. And so that's it. That's our difference between discrete and continuous functions. Enjoy.